All right, in this video, I'd like to discuss the uneven heating of the Earth by the sun, and really the impact that has on weather and climates. Let's talk about a couple of. There's really three key factors, but basically, this uneven heating of the Earth will, in effect, it affects basically, I should say. It affects heat and precipitation distribution. Heat and precip distribution, DASTN, okay, for a thing. And there are three causes of the uneven heating. All right, the first one, I'll just call this A, and I'm going to draw a little diagram for you in a minute. Variation of the angle at which the sun's rays strike the Earth. So variation of the angle of the sun's rays. All right, hitting the Earth. All right, if I was going to draw something like this, I'm going to draw a little, just a little abbreviated. Here's my equator. Here's the Earth. And the sun's rays are coming in like so. All right, if it strikes the equator here, all right, it has a distance to travel. When the sun comes in up here, the distance to travel when it hits the poles is much longer. All right, longer distance. All right, that the sun's rays travel. You can see the much longer distance, which means that there is energy lost as it travels through more atmosphere. So I'll just say equals energy loss. All right, so this is a shorter distance, much more intense here for that. The second factor kind of has to do with the angle, but basically the second factor has to do with the amount of surface area all right, over which the sun's rays hit the Earth at different points. Strike the Earth. And if I had to draw a brief illustration of this, over here, I'm going to draw it a little bit differently here for this. Here's my equator here, more of a 2D. All right, the sun's rays are coming in like this, almost like at a perpendicular angle. All right. And whereas the sun's rays up here are more of an oblique angle. So the angle is more oblique. All right, oblique angle. All right, which all that means is that the sun is spread out more over a larger landmass, a larger surface area than right here near the equator. It's much more concentrated. All right, so I'll just say more concentrated, conct at equator. So that's the second factor. So the three factors: the variation of the angle of the sun's rays hitting the Earth. At the poles, you can see the sun's distance which is going to have more time for that the sun's rays to be in the atmosphere. Energy loss, there's going to be less energy hitting the Earth than it would be if it was a shorter distance. The second is the angle that it hits leads to much more concentrated sunlight, a smaller surface area at the equator as opposed to at the poles where the energy is much more spread out. The third factor has to do with something called albedo. But this has to do with some areas of the Earth reflect more light than others. All right, and basically the percentage, I'll say the percentage of light, all right, reflected from its surface let's say from the Earth's surface, all right, is called its albedo. ALBEDO. All right. So basically, a higher albedo equals a higher reflection rate. Equals higher reflection of the sun's rays and cooler temps. All right, and we knew that white light has an impact here also, or white colors, I should say. White areas, or areas, I'll say, reflect more light. All right, so that's the third factor, is the albedo. The third factor contributing to uneven heating of the Earth. All right, thank you very much.